let's begin and welcome everyone to the seminar. I salute you from the main office of Alfa Laval in Ontario, in Scarborough. And I'm going to start my presentation talking about a topic that is a word that we hear a lot these days, sustainability, and how to use welded heat exchanger solutions to improve your sustainability. Now, like I said, this is a word that we hear very often these days, and sustainability has changed the way organizations are making decisions, because now they are taken in a more systemic approach. Now, also sustainability to me means making actions now, but with your eyes put in the future. So why are we talking about sustainability in a heat exchanger seminar? Now, to start, I'm going to play a very short video to show how Alfa Laval technologies connect with the sustainability goals of your different industries. So let's watch that video.
Sustainability. We hear that word a lot, but what does sustainability really mean? For Alfa Laval, sustainability means technology that supports both your profitable growth and a positive environmental impact. It's all about giving you long-term confidence in your production, along with the lowest life cycle costs. Alfa Laval offers a wide portfolio of welded heat exchangers that help customers to continuously improve sustainability through energy efficiency. With solutions to support a huge range of applications, they boost thermal performance and ensure reliable operation. But it's more than just technology. It's the people. Helpful experts with knowledge from decades of heat exchanger experience, excellent project execution, and a global service network that is there throughout the product life cycle. Sustainability is not a sprint. Just like the development of your business, it's an ongoing process. And when you choose Alfa Laval, you choose a partner for the long run.
So these are very inspiring words. And there is one main concept that I want you to take with you from this video. And the main concept is energy efficiency. Now, energy efficiency is very closely related to heat transfer equipment and heat transfer technologies, because what can you ask for is a very high thermal performance, but also reliable operation with minimum waste that a heat exchanger can provide. Now, there is something more that was mentioned in that video, which is the clean technologies. We all work in oil and gas, chemical industries. So how can clean technologies be applied to our processes? How can we make our products more clean or processes more clean? So one way of approaching that challenge is to reduce carbon emissions to the atmosphere. Thinking outside the box, how could we help cut CO2 emissions equivalent to 30 million cars? One option would be to ask all Canadians to stop driving cars right now. Obviously, that is not a reasonable request. And we have to look at other options if we really want to achieve this goal. One option is to look at our plants and our operations. For example, take the refinery industry. Well, the refinery industry is a very energy intensive industry. But it is estimated that by switching from existing shell and tube technologies to more efficient welded technologies, the energy consumption in refineries can be cut down up to 25%. That 25% energy consumption means is converted into 120 million tons of CO2, which is equivalent to the emissions of 30 million cars. Now, I know in this slide it says it's easy, but it's not. It takes a lot of effort and it takes a lot of commitment from different players globally. But if this message resonates with you, be sure that you're not alone in this, and you can count on us to help you. So let's get started. Now to our main topic of conversation. It's welded heat exchanger technologies. Our presentation today is going to be more focused on the two main players, which are the Compabloc and the spiral. However, I also wanted to make mention of all the other technologies that we have in our portfolio. Some of them might be familiar to you, some of you at least. For example, I like this slide very much because it's the products are lined up here, all the products from extra small to the extra large. And if you look at the first one on the left, the extra small is the Alfa Nova, which is our main solution for very corrosive and high temperature applications. You may be familiar with this product if you work in the gas compression industry, for example, because we supply a lot of these exchangers for gas cooling and oil cooling applications. Now, we also supply air coolers and wet surface coolers, which are mainly doing heat rejection, but also very helpful when there is little to no water in your installation. So they can supply the cooling of the whole plant without using a single drop of water. And we also have the printed circuit heat exchanger, the all-me shell and tube heat exchanger, yes, shell and tube, and the Packinox plate heat exchanger. So these three are in a separate category because they are niche products developed specifically for a certain application in the refinery and the petrochemical industry. But like I said, in this presentation, we are going to be highlighting the Compabloc and the spiral because these are the leading technologies for general purpose applications in the process industry. And we're going to start with the Compabloc. Now, the Compabloc is a welded plate heat exchanger. It has similarities with the gasketed plate exchanger, which I'm sure that you already are familiar with. And it's based on the same concept of corrugated plates that provide a very high efficiency because of a highly turbulent flow, which also promotes a higher heat transfer coefficients within the design. Now, there are differences between the gasketed design and the Compabloc design. The main one being that the gaskets between plates have been totally eliminated. The Compabloc plates are bound together by welding. So there are no gaskets in contact with the fluids. So that helps provide a wider range of applications in terms of chemical compatibility, temperature, and pressure. Now, other key difference in the design of the plate and frame, gasketed plate and frame and the Compabloc is the plate itself, because gasketed plates are typically rectangular and long. Compabloc plates are square and shorter. And with the gasketed plates, we have developed different styles of corrugations to adapt the design of the gasketed exchanger to many different possibilities on many different surfaces. Now with the Compabloc, we only have one style of corrugation. And this corrugation is diagonal at 45 degrees. Why 45 degrees? This is the ideal angle, not only with heat transfer in mind, but also to make it easy to access for cleaning. Now, I'm not going to talk too much about cleaning because Garth has a complete section on service after my presentation. But I'm just going to mention that, highlight that difference between Compabloc plates and gasketed plates. Now, if we only have one choice of plate with the Compabloc, how can we make sure that our design is capable of meeting all the different service scenarios or all the different service demands in the industry? Well, one way of approaching this design challenge is by making the Compabloc multipass. And this is another clear difference between the gasketed and the Compabloc design. In gasketed, it is often requested that the design should be one pass because of convenience of having all the connections on the same, on the frame plate on one side. Now with the Compabloc, it's completely the opposite. Now with the Compabloc, we always want to have multi-pass configuration. And this is because we are not too concerned about the location of the connections, but we are concerned about the thermal efficiency. And I'm going to give you an example of that by showing a short video. Okay. So this is the Compabloc liquid-liquid configuration. And what you see here are pass plates. Now these pass plates are dividing the Compabloc plate pack into different sections. Now each section behaves as a heat exchanger on its own. And now when the fluid comes in, it gets directed to pass multiple times through the same heat transfer area. That elongates the shape of the plate by making it a longer path through the heat exchanger. This longer path gives a longer residence time inside the heat exchanger and allows a closer temperature approach between the hot side and the cold side. Now you can say shell and tubes can be designed with multi-pass configuration too. Yes, probably you can add multiple passes on the shell. However, in the Compabloc, you can add multiple passes on both sides. So you can really adapt the same heat transfer area to multiple demands in thermal performance by adding or removing pass plates to match the thermal performance required. Now you will say, Monica, but the adding pass plates, it's also reducing the cross-section area of the heat transfer for the fluid. So it will also increase the pressure drop. Yes. And how do you balance that? Well, that's the reason why I have a job. There must be a balance between thermal efficiency and pressure drop, and that's what we strive to achieve when we design a Compabloc heat exchanger. Now, the Compabloc can also be used in two-phase applications or two-phase services, such as reboiling or condensing. And this is the reboiler configuration. Now you see it. And now for the reboiler, we have put the plate pack on a horizontal position. And now we have vertical channels for the reboiling fluid to pass through. So the Compabloc reboiler is a very, provides a very short length. So it's a very efficient and it provides a very short, a very low pressure drop. So it's ideal for use as a reboiler. And on the colds, on the heating side, then typically if you are using steam, we also have a single pass configuration for the steam side. Now, why don't we use multiple passes in a reboiler? We would if we have a liquid cooling media, a liquid heating media, sorry. But for steam, since we are using the latent heat of the media, we don't need a larger or a multiple pass heat exchanger because we are not too concerned about temperature approach. We are just concerned about providing the most efficient path for latent heat to be transferred from one side to the other, from one fluid to the other. and that would be our reboiler configuration. Now, if we had if we had two wishes, two features, or two main wishes for what would be an ideal heat exchanger, I'm sure the first thing we would ask is to have a very efficient thermal performance. The second one would be reliability. And Compabloc has been developed as well to provide higher reliability options for very demanding processes, and especially for high pressure applications. So Alfa Laval has developed a new sealing concept which is called the plus seal. You can see on the screen right now. So for the plus seal, we have created a gasket groove. And so now in this design, the gas is confined inside that groove. So, and it works two ways. The groove is now protecting the gasket from crushing. That can happen when you over tighten the heat exchanger, but it's also providing a metal to metal surface contact. That also provides a better seal for high pressure applications. So this is a recent development of the Alfa Laval technology, of the Compabloc technology, and designed specifically for performance up to 60 bar, which is covering a lot more application range in the industry. And it's applicable to and it has the same, all the same features that the rest of the Compabloc range has in terms of materials, in terms of design codes, and in terms of applications. So with all these developments, we can conclude that the Compabloc can be defined as the most compact and efficient welded heat exchanger. And it provides not only the thermal performance, it also provides more energy recovery in a small footprint, and it also provides reduced service and reduced cost. So it is a very good alternative to shell and tube installations all across the industry. Now, we're switching to the next product. We talked enough about the Compabloc. Now we're going to talk about the spiral heat exchangers. Spirals are very well known because of their ability to handle very fouling media and solids. So you might be familiar, and some of your organizations may have installations of spirals somewhere in their plants. So I mentioned before, it's an ideal heat exchanger should be not only very thermally efficient and also reliable. If there was a third thing to wish for, it would be a heat exchanger that, well, that hopefully we don't have to maintain or clean as little as possible. And the spiral heat exchanger addresses this demand. The spiral heat exchanger is very unique because it has the ability to provide self-cleaning of the internal channels. This is a very important feature for very fouling media because, and the way that it works is the moment that fouling starts to occur, there is a reduction in the cross-section area. There is a start to build up inside the channel of the spiral. And this buildup will increase the local velocity and will also increase the shear stress in that localized section. Shear stress provides shear forces that will actively remove the deposit of fouling and push it away, push it outside the heat exchanger. So that is the way that the self-clean feature works and performs inside the spiral. And this is very unique to the spiral because the spiral is the only product that has a single channel configuration compared to Compablocs or shell and tube, where you have multiple flow channels through the heat exchanger. The spiral heat exchanger construction is a single channel. So it facilitates, it provides the ability to supply this self-cleaning effect. Now, self-cleaning is very often required for liquid services. So how does a liquid spiral look? Something like this. So the benefits of the spiral is, first, of course, no fouling and clogging. So very reliable operations and very long run times. Spiral is also very easy to open and clean, and that reduces the maintenance cost for the plant. Applications throughout industry, any kind of fluids that can contain solids or fibers, for example, like in the pulp and paper industry, liquors, slurries, like in the mining industry, and sludges, for example, municipal sludges. So for very demanding liquid applications. Typically mounted horizontally, this is how the spiral would look like. And we have hot inlet at the center of the spiral, then moving through the heat exchanger around the center, and outlet of the hot side on the shell side or the periphery of the spiral, and the cold side or the cold fluid moving in the opposite direction. Now, something that you might not be aware of is that the spiral is also very much used as a two-phase condenser. So condensing vapors, especially when very low pressure drop is required. So ideal for vacuum condensation because a spiral can be designed with a very large spacing in the channel. So that allows for the vapor to condense with very low pressure drop. While the cooling side still works in a spiral path, providing the self-cleaning effect for the cooling medium. Here we have the cooling media going in a spiral path with self-cleaning ability. And here we have the vapors coming from top and exiting at the bottom as a condensate. Now you will notice that this spiral configuration has a small outlet here on the side, and this is for non-condensable gases. So here in this type of configuration, we also have an additional benefit, which is can separate the condensate from the non-condensables inside the heat exchanger. It's not required to be done separately on an additional vessel. Just to summarize, then, the spiral heat exchanger is the best solution for fouling and very dirty media, which also helps with the thermal performance and provides the ability to high energy savings in a very compact footprint. Now, we've talked a lot about the products, but I'm sure that you want to hear about this service. So I'm going to hand over to Garth, who is going to take us to the service side. Garth, the floor is yours. I'm going to start presenting and take us through.
All right. Thank you very much, Monica. That was fabulous. So Yeah, no, we're going to get into the service side. So once you all have your exchangers installed, you know, they're going to be a life cycle on them, and this life cycle is going to involve service. And so the beauty part about Alfa Laval is they have the support locally, right across Canada, and with the large install base they got, and with the wide range of welded heat exchangers they have, you know, we want to make sure that we can get out there and support the clients in any way we have to. So again, I just want to reiterate that we're going to be talking about just the welded kinds today. Alfa Laval, and probably most of you know them as with the gasketed exchangers, the gasketed plate and frame units, and this is what we use service mostly in our Edmonton service shop and Scarborough. But today we're just going to be focusing on the welded ones, and there's a lot of similarities between the gasketed units and the welded, but the gasketed ones will be at a later date. So that's why we're going to be focusing on the welded. Okay, so I should turn on my camera here too, I guess, eh? There we go. So for welded exchangers, the ones that we're supporting in our shops right now and with our field service and engineering is obviously the Compabloc and spirals that Monica went through. And then we're also still supporting a couple units that aren't being made right now. And these units are our Durashell, which is our plate and shell exchanger, and also the Alfa Rex. So the Alfa Rex is an all welded up plate pack. There's no gaskets. I know it looks like a gasket unit, but it's not. So we still support these units also, and also with our braze line, but this is where we're actively working on and can help everyone with. And these are the service centers around the world. So this is a good shot of Alfa Laval's global presence with all their shops. I actually counted these blue dots, and I counted 71. So it is quite a presence around the world, and with that many shops, you know, and sharing best practices, you know, the right thing is being done all the time when the units come into the shops or when we're sending out the field service techs. Okay, so I first want to start off with a couple programs that we're keen on, and we want to grow them because we feel there's a lot of value in them. We really want to get away from reactive service and maintenance, and we want to get more on the proactive side. And a good way of doing that is doing performance assessment. So a performance assessment obviously is we're assessing the performance of the heat exchanger. So these are done when the heat exchanger is in service. We want to see what the unit is doing for outlet temperatures and flows. So we're going to do the first thing is a data collection. And with this data collection, we can go out and grab the data ourselves with our instruments, or if the client is confident in the data that he has, we can take that data, and what we'll do is we'll punch it into our design software, and we'll start doing the thermal review on it. So this design software is exactly the same software that we use to design the actual exchanger. So it's going to be very, very accurate. So with punching in parameters that we're seeing existently, we'll be able to tell the performance of the unit, you know, how fouled it is, percent efficiency. And when all the review is done, a performance assessment report is then handed to the client for that particular heat exchanger. And this document is a very valuable document now. It can be used for detailed maintenance planning. It can be used for shutdown turnaround planning. The technical groups love it for managing the exchanger. So it's a program that we hope a lot of you guys take advantage of it, and let us do that. The other program is the condition audit. So the condition audit is when it actually comes offline. So the unit will be offline, and we're physically going to be touching this thing. So either it's coming offline for some planned maintenance, it's coming offline for one of the 4 or 5 year inspection periods that has to be done. And what we'll do is, it's kind of like a reconditioning job of a gasketed unit, but in this sense, it is like reconditioning up one of our welded units. So if there is no repairs to be done, what we'll do is we'll open it. We'll be doing a pre-open hydro, disassembling accordingly. The pre-open hydro actually is pretty valuable. That will tell us what, if either side is failing externally or cross-contaminating. Then we'll get into a visual examination, just making sure all components are in good shape and see if anything has to get replaced. Obviously, we'll do a good cleaning of it. We want to get this thing back to brand new condition is the whole intent. So we'll get, and I'll get into cleaning here in a few more slides, but cleaning is very important to get it back to brand new condition. And then once it's brand new clean, we can start doing dye penetrant checks and more thorough inspection of the unit. And then from there, if we do find any faults and we have to do some repairs, this is the time to do it. And we've got very qualified procedures and welding procedures. So very, very comfortable with doing that in our shops, and we get the proper people involved. And then we'll reassemble the units with new gaskets, and we'll do another hydro test. And once this is done, it's going to be like a brand new exchanger, and a final service report is done. And again, this report is very valuable for keeping for your records, and for planning and for turnarounds, and for how we're going to manage and operate this piece of equipment for the future. So in the life cycle of a heat exchanger, cleaning is probably the number one thing that gets done to it. Cleaning, I don't know any exchanger that does not need a clean job once in a while. And when you do have a piece of equipment that has a hot and cold fluid going through it, it is a good target to get fouling. Velocities usually slow down when you're going through an exchanger, so that's when debris will build up. So being a service company of heat exchangers, we had to get really good at cleaning, and in all aspects. So here you'll see, we're going to be focusing on the mechanical cleaning, chemical circulation cleaning. We have our submersible tanks in our service shops to dip whatever we need to dip that way. And then we also have alliances to do ultrasonic cleaning, which is very effective in certain situations. So for the mechanical cleaning, obviously it's just doing pressure washing, doing some hydroblasting, and cleaning it up. So we do have to open up the exchanger in this sense. It's getting taken offline. This can be done at site. It can be done in our service center. And we have a third-party alliance company that has their cleaning center also. So we will be able to tackle this type of cleaning any way we need to. We don't want to open up a heat exchanger if we don't have to, but sometimes it does come down to that, where we do have to open it up. And the beauty part about our welded heat exchangers, well, the Compabloc and spiral anyways, is you do get full access to both sides, like Monica was saying, and that is very, very valuable when you are able to do that for cleaning and inspection. So this is why these exchangers are going to be getting more popular all the time, replacing more shell and tubes all the time. Now, this is the most popular cleaning of the exchangers that is being done out in the industry, and we're a fan of it also. We think it's, we have cleaning crews that we send out, and our cleaning crews are almost out full time right now. And the reason it's so popular is because we don't have to open up the exchanger. And within one shift, 6, 8, 10, maybe 12 hours of chemical circulation cleaning, this exchanger is back up to brand new and being able to hand off to operations, which is really very valuable. And because of this, we are ensuring, and we want to encourage all you out there, especially our engineers, where if you're designing the install of an exchanger or a plant, make sure that in between the isolation valve and the heat exchanger, you're putting cleaning nozzles. And I'm not sure if you can see my mouse here or not, but here's your isolation valve, here's your heat exchanger. This is where you want to have it on both your inlet and outlet. And determining if both sides are dirty, you do want to do it to both sides. If you know one side's always going to be clean, like glycol or whatnot, I guess you don't have to do it. But those are going to be some pretty valuable nozzles in the near future, that and have them at a good size. Like we're looking at 3 to 4 inches is a really good size for chemical circulation, and making sure we get enough flow. So when it comes to chemical cleaning, I've talked to people and they say, yeah, no, we've done that before, it didn't work. And I just want to emphasize a chemical clean has many different aspects to it. And so when I hear that, I always wonder, well, did you have the right cleaning chemical? Was there any lab work done? And make sure that you got a customized cocktail there that we know is going to be very effective for that particular foulant that we're trying to take off that surface. All right, and what was the flow rate? Did you have very good flow rate when you were circulating? You need to have good flow rate to have a little bit of shear stress where you're constantly taking off the dirty foulant as the chemical is working its way down through the foulant. And we want to make sure you're getting an effective temperature in there, so the solution is working properly at the proper temperatures. And then time, we got to make sure we're circulating at the right times. And the best way to know if you're circulating at the right times is with on-site lab testing. And this is exactly how we do our cleaning jobs out at site. And with this lab testing, we're able to know that we're cleaning for the proper amount of time, and we'll know our endpoint. So we can pretty much guarantee that we're getting a good clean and that the chemical was effective. And if we have to make any tweaks to the chemical during the clean, that's we're able to do that with continuous on-site lab testing. Another popular method of cleaning is with ultrasonic. Ultrasonic's getting very popular. I presume a bunch of you guys are doing chemical cleaning already out there. And this is going to get more popular too, I believe. It's a great way because when you're dipping bundles and Compabloc hearts, you're cleaning both sides of it. You're cleaning the hot side, the cold side, the tube side, the shell side, whatnot. And as you can see in this tank here, it's lined with a bunch of transducers all the way around the tank, and these transducers are putting out these high frequency sound waves that is causing a cavitation implosion, which creates these really tiny microbubbles that just do amazing scrubbing action of the surfaces. And we're able to take paint off of some exchangers if we leave it in long enough for ultrasonic cleaning. And then I know we don't like going this way too much, but sometimes we need a repair. And either you got an external leak or an internal leak, or just something's worn out. We have to do that once in a while, right? So we're fully prepared to do whatever we need to do. This is all over the map on how bad the damage is that we have to do, like, can we go and do the repair out at site? Can we do it? Does it have to come into a shop? Does it have to go to one of our ASME certified shops to get the repair done? But we're able to help in all those areas, whatever we need to do with those welded units. Spare parts, this is one thing I actually preach this one. I'll admit it. I'm a big fan of spare parts because I'm not a big fan of emergency situations. So I always highly encourage to make sure we have the proper spare parts. So within a Compabloc, a lot of it determines on how severe, not severe, but how important the application is to your process. And if it's really important, I would have a spare Compabloc on hand. You know, they're if you ever had to use it, it would be well worth the capital dollars to get that spare part in there, or spare Compabloc in there. Sometimes you just need the heart if you have the time to do a heart swap within your panels. But that's not really that easy. It's not as easy as swapping out a plate pack and a gasketed unit. This is a little more extensive. So, but having a spare plate pack is definitely better than nothing, but not as good as having a complete spare unit. And with spirals, also, spirals are a little bit more robust. So, and most of the time there's more redundancy of equipment for spirals. So there is no spare cores or anything for a spare exchanger, but if it is an important enough application, you would like to get a spare unit in, and always want to get some gaskets on hand, either panel gaskets or door gaskets, if it's the Compabloc or spiral, and some ear lugs if you have spirals. It's always nice to have some spare ear lugs to close those doors up. But I'm a big fan of spare parts, and because I'm usually one they call when they're in an emergency, and I would rather avoid that. So, all right. So we have a couple. I'm just coming in for a landing here. A couple more slides. This here is a program we're just introducing, where if you give us your serial number of your exchanger, we're able to give you a customized, detailed maintenance plan for that exact particular exchanger for that serial number. And it will be a very valuable document, which will give you the recommended service and intervals for that exchanger, detailed service scope for each, and recommended spare parts. Okay, so hopefully a lot of you out there take advantage of this. And then to go one step further, we are wanting to get more and more into service agreements, and we're promoting service agreements with our clients and getting more involved with how we're going to manage these exchangers and how we're going to do the maintenance and how we're going to be doing the spare parts and whatnot. So we're hopefully that will tweak some interest, and we would love to help you out on getting some service agreements signed up so we can help in the managing of your exchangers. So we're doing more proactive stuff and not so much reactive stuff. That's probably one of my key things I want to get across to y'all today is that. All right, and then we're big on the customer training. We know Compablocs, spirals aren't as common as shell and tube exchangers, so we've done it many times where we go out to the client site and we're doing some training, and it's particular to those exchangers that are right on their site. So please don't be shy to ask if you want to have some training done at your site for your particular units. And we obviously do it for the gasketed units too, but any type of Alfa Laval exchanger, we got on-site training. Okay, and this is a popular leaflet that we have. We've blown it up and even done posters out of them and laminated them, and we are going to be sending out an email with the replay to this presentation, and also and also the presentation itself. And within that PDF presentation, we are going to have a link to these documents here. A lot of our clients have laminated them up and put them in their control rooms or conference rooms or whatnot as a guideline to looking after your Compablocs and spirals, the top 10 tips. And then we got many other resources, very popular on the LinkedIn, Facebook, YouTube, and our website. So we got a lot of resources, and this will also have the links all active in the PDF presentation that we're going to be sending out to everybody. So you all will get full access to that too. So, all right, and yeah, that's all I had to share with you today. Thank you, John and Jamie, for all your help and support in this, and especially you, Monica. You did a fabulous job, and I know you're super busy, and it was hard to squeak this in here, but you did it, so I really appreciate it. Thanks, everyone.